As it shows this one. So we're doing May, June 2024, right?
Yeah.
Okay.
Okay.
And Neem, I opened the wrong one. Just 1 second.
Okay.
This is actually physics.
Yeah, we're 9701.
Yeah, I don't know why it's opening physics. Hold on a second. Try to get this one. So we've got this paper, which is so like we didn't do this one, right?
Yeah, we haven't done this one.
As I explained, the lack of reactivity of nitrogen gas. So why is nitrogen gas so unreactive? Give me 2 points. It's a 2-mark question.
Because they're double bond. They have triple bonds.
Because the first one is it's got a very strong
attractive force.
triple bond.
Yeah, and it's also because they're non-polar.
Yeah, the second thing is that they're non-polar. So that's point number 1. This is point number 2, that they are
Non-polar.
non-polar. So they don't really attract molecules. Next one, what's the number of bonds of sigma and pi in the N2 molecule?
Sigma has 1 and pi has 2.
Okay, so there are 2 pi bonds and there's 1. So in a triple bond, the first bond is always a sigma and the rest are all pi bonds. How do the orbitals overlap in a sigma bond?
Sigma is direct while pi bond is sideways.
Okay, so that's sideways.
And direct.
This is end to end, right?
Yeah.
A sample of Al reacts with Cl2. State the oxidation number of Al is the product of the reaction. The oxidation number of Al is always the same. What is the oxidation number of Al?
+3.
Okay, that's +3. State what determines the maximum oxidation number of the period 3 elements in their oxides. What determines the oxidation number of period 3 elements?
The valence electrons.
See, it's the number of valence electrons. That's the number of bonds that they can form, right?
Yeah.
Like Cl has 7 electrons because they're not limited by the outer shell. There's no octet rule. Cl has 7 electrons. Cl can possibly share all its 7 electrons, right? So give the state of Al2O3 and P4O10. What is the state of P4O10?
P4O10.
Al2O3. What's the state of Al2O3?
Al2O3 is gonna be solid.
Yeah, that's a solid. They're actually both white solids.
Oh, okay.
This one is also going to be. This one is also going to be a solid, right? You get clear? I said then the next one is that. I said so the next one is write an equation for the reaction with NaOH.
Plus NaOH cube. You'll get a.
Remember, Al2O3 is amphoteric, right?
Yeah, it reacts.
So what happens when it's amphoteric? What salt is produced? I mean, it's an O levels. You study this in O levels as well.
Plus,
Hmm?
oh, L2s. This is gonna
It,
give you,
it was sodium eliminate plus water, right?
yeah.
Or you can write NaLOH4 as well.
Yeah.
And what happens when P4O10 reacts with NaOH? What is produced? Remember P4O10,
Na3 PO4
yeah, it's going to produce NaCPO4
plus
plus water.
water. Plus water.
Plus water, because remember P4O10, when it mixes with water, it forms phosphoric acid. So you're basically thinking of a reaction with phosphoric acid.
Mhm.
Calculate the oxidation number of silicon in calcium silicate. So what's Ca is group 2, right? It's plus 2.
Yeah.
Oxygen is minus 2. What is silicon then?
0. It's supposed to be 4 plus 4.
It's going to be plus 4 because this is minus 2 times 3. And this would be x, and the whole thing is basically neutral, so it's going to be 0, and that's going to give you.
Plus 4.
So calcium oxide can be made from calcium carbonate, right?
Yeah.
They didn't ask for the equation, but what's the equation, by the way? And what is the reaction called?
Oxidation.
The equation is when you heat a carbonate or a nitrate, it decomposes, right? And that's known as
The decomposition. Thermal decomposition.
it's thermal decomposition.
Yes.
So then you have this is I guess that's the Haber process, right?
Yeah.
So so there's the Haber process. Now he says describe and explain the change, if any, in the percentage yield of NHC produced in B compared to A. I mean, the only difference is using the same temperature, using the same pressure, except that one has catalyst and the other one doesn't have catalyst, right?
Yeah.
So what difference would it make to the percentage yield?
It would increase.
What does the catalyst do to the equilibrium?
Oh, it speeds up the reaction, shifts it to the. It won't have. It won't have any effect because of the catalyst. It just increases the reaction speed. It doesn't
Okay,
change
so
the effect.
so you have to explain, right? And in the
Yeah.
explanation, what you're going to write is that the catalyst only speeds up the reaction, right?
Yeah.
Or it speeds up both backward and forward reactions equally, right?
Yeah.
So catalyst only speeds up reaction rate, doesn't really affect anything. Okay, no change. So it's going to remain as 58%. So X over here would be, the yield will be exactly 58%. Describe, explain the change, if any, to the percentage yield of NHC produced in C compared to A. So what's going to happen in C now? The only difference is, I mean, the catalyst is gone, but he's not asking about the rate, right?
Yeah.
No, he's asking about the percentage yield. Sorry, not the rate.
Okay.
So He's increasing temperature.
Yes.
What would that do?
That will decrease the yield.
Where will the equilibrium shift?
It will shift to the shift
Endothermic or exothermic?
exothermic, so it will shift forward, be forward reaction.
No, when you increase temperature, endothermic reaction is favored. So it's going to shift backwards, right? Always remember increased temperature, that's endothermic, because the one that needs energy, that's the one that's going to speed up, right? So it's going to shift. This time explain the change, if any. So it will decrease, right? Why you have to increase in temperature favors endothermic? Which is backward. Okay.
Yeah.
Describe and explain the change to the rate of the forward reaction. Now he's talking about the rate of the forward reaction. Occurs to establish the equivalency compared to A. You don't need to refer to the Boltzmann distribution in your answer. C compared to A. Remember the question is about rate.
Yeah.
Okay, what's the difference in the rate?
A has a lower rate compared to C
Why?
because the temperature is lower in A.
A has lower rate.
Yeah.
Why? Because A has lower temperature.
Yeah.
But so explain further, right?
Yes.
What does lower temperature do?
It lowers the activation energy needed for
No, the
the
activation energy is only lowered by a catalyst.
it increases the
The particles have less energy, right?
yeah. Yes.
So they have less frequent and effective collisions.
Oh, yes.
Okay?
Yes.
So they have less frequent and effective collisions. Write an expression for the equilibrium constant Kp. You have to write an expression for Kp. What's the expression for Kp over here?
KP over here would be
What?
expression for KP is products over reactants. Right. It'll be NH3 to power
No
2.
partial pressure of NH3
It's 3 to the power 2 over partial pressure of
NH2
N2 to the
power
1
and then partial pressure of
H2 to the power of 3.
ठीक है.
And wait, 1 second, we have to do the unit. Wait, moles.
He's asking for the unit? Yeah.
Yeah, that's gonna be, since it's squared and then it's squared, it's gonna be 1/2. So atmospheric pressure to the power -2.
Yeah, that's what a Kp is, right? As a right expression for that's done. Now, equilibrium mixture D is made when 1 mole of N2 and 3 moles of H2 are added to a sealed container and left to reach equilibrium. This mixture contains one. So you have to now make that table now, right? It's and then you have so what's your initial moles? He adds 1 mole of N2, 3 moles of,
H2.
and there's no moles of NH3, right? Initially, then you have equilibrium.
Mm-hmm.
So at equilibrium, you've got 1.16 moles of NH3.
Yeah.
So tell me, what are the moles of the rest of the substances?
Since they're supposed to be in the products are supposed to be in a ratio 1:3. No.
You tell me the final answer. What's the
We're gonna do 1 minus 1.16 and 3 minus 1.16.
nay? What's yeah? How many got produced over here? It's 1.16, right?
Wait, yeah. So we're gonna do 2 into 1.6. 1 minus 2 into no 1 minus 1.16 divided by 2.
Okay, so 1.16 divided by 2 reacted, right? And over here, it's going to be
3 over 2 because it's multiplied by 3 then divided by 2.
3 over 2 into 1.16, right?
Yeah.
So calculate the equivalent moles now. It's going to be 1 minus 1.16 divided by 2, right?
Yep. That is gonna give us 0.42.
0 point?
42.
And what's the other one? 3.
The other one is 1 second, I'm just doing it. It's gonna be 1.26.
1.26? Are you sure?
Yeah.
That's it? Okay, so 0.42 and 1.26.
Yeah.
Now, what is he asking? Calculate the mole fraction of NH3. So now you have to calculate the mole fraction. You've got your equilibrium moles now, right?
Yeah.
And you have to calculate your mole fraction for NH3. That's easy now because it's going to be what? It's going to be just the mole fraction. So that's 1.16 divided by the total, which is 1.16.
Mhm.
So what do we get?
Gonna be 1. It's gonna be 0.4. Wait, the fraction is 29 over 71.
Yeah, so what is it? 0.4 what?
0.408.
Okay. The mole fraction of N2 is 0.625 in a new equilibrium mixture. Calculate the partial pressure of N2 in E.
You
So how do you
multiply
calculate
by
partial?
1,000.
Yeah, that's
Multiply
it.
by 1,000.
See, it's mole fraction multiplied with total pressure, right?
Yeah.
So 1000 into 0.625, right? So it's 625, right?
Yes.
So that is 625. Next question. When oxides of nitrogen escape into the atmosphere, they may be involved in formation of acid rain from sulfur dioxide, formation of petrochemical smog. Identify the role of NO and NO2 in the formation of H2SO4 from SO2 in the atmosphere. Use relevant equations to support your answer. So basically what you're looking for is acid rain formation, right? So how is it formed? It's SO2 in the atmosphere, right? And NO2 in the atmosphere. And they react and they form SO3 and then that NO oxidizes in air by itself.
Yeah.
So identify the role of NO and NO2 in the formation of acid rain. So they're basically acting as a catalyst, right? Is that clear?
Yeah.
And now you have to write an equation for formation of acid rain. So that's the SO3 reacting with water to form. So that's your acid rain getting formed.
Yeah.
That's it. That's the next one. Outline how NO, NO2 may contribute to the formation of petrochemical smog. What is petrochemical smog? Photochemical smog, sorry.
It's when all the carbon monoxide and other gases are given out by the catalytic converter in the car.
Meaning photochemical smog. Remember, this is a new thing that's been added. This is peroxyacetyl nitrile nitrate
Yeah, and then the unburned hydrocarbons, which will combine with the NO2.
with NO and NO2, right?
Oh yeah.
And they end up forming, and the result is they end up forming PAN, which is peroxyacetyl nitrate. Okay.
Mm.
So write an equation for the standard enthalpy change of formation of H2O. What's the equation?
The equation hydrogen plus oxygen gives us H2O.
And it's basically, oh, how do you balance it?
A half oxygen.
Okay, 1 mole of a compound is formed from its constituent elements, right? So this is a
And
gas.
gas, liquid.
You got an equation and they've given you the enthalpies of formation, right?
Yeah.
What's the formula when you, how do you calculate the enthalpy of a reaction? Using enthalpies of formation. Kya tha, what's the formula for that?
The formation of products
Nothing
minus
minus formation of
So calculate this quickly. You got the products Bn, that's minus 134 times 2. You got water, which is minus 286 times, and that's going to be 3. Minus the products, which are, you got minus 1264. And the other one is 2 NH3s, so that's minus 46 times 2. This all will get converted to plus, right? So Kiara, what are we getting? As a kid, did you try this?
The answer is coming to negative 2482.
Negative 2, 4?
2482.
No,
Negative
that's
2,
wrong.
4. That's wrong.
You see, minus 1264, that's going to become plus. 2 times 46, that's also plus. 134 times 2, 3 times 286. Let me try this again. One second. Here, 134 times 2 minus 134 minus 26 times 3. That's a plus 1264 plus 46 times 2. I'm getting 230.
Let me do it again. I'm doing. I'm getting the same answer now.
You can be
234.
very careful with your calculator. Now, the next part is suggest the structure and bonding in boron carbide, which he says is it's got a very high melting point.
The hard crystalline solid.
So what's the structure?
Structure, I think.
No, it's a giant covalent or a macromolecular structure.
Oh yeah.
And then he says calculate the empirical formula of boron carbide, right?
Yeah.
So 100 grams of boron carbide has this much boron, right? So it's got boron and it's got carbon in it, right? So boron is 78.26 grams, right?
Yeah.
So बताओ कि carbon, what is the amount of carbon that you have in this?
We have 78.20 hundred. Wait.
What's 100 minus 78.26?
It is 21.74 grams.
Because how do you find empirical formula? You divide by the molar mass, which is, I think for boron it's 10.8 in the periodic table. For carbon
Yeah.
it's 12.
12.
So you find the moles of both. What's the
Or
first one?
7.2463.
30 if you see them figures. What's the other
Okay.
one?
The other one is 1.81.
And then you have to find the whole number ratio, which is divided by the smallest.
Yeah, 1.81 by both.
So what did we get?
For boron, you get 4, and then for carbon, you get 1. The
So it's B4 and
B1, C1.
TK. Describe, you basically have to draw NH4 plus 1, and you have to show all the ionic, covalent, and coordinate bonding, right? So normally it starts off with what, NH3, right?
Mhm.
So normally it starts with so this is your NH3 molecule. And then an H plus 1 comes in and joins with it because it needs 2 electrons, right? So it forms a dative bond, right?
Yeah.
So you've got this NH4 plus 1. And then you have a Cl ion, which has 7 electrons.
Mm.
And that's basically your -1, right? So you have to label your bonds as well. I guess you have to label them. So this one is draw a diagram to show ionic covalent. I guess you have to. You can tell them that this is your dative bond. Those are your covalent bonds. This one is your ionic bond, right? So is this one clear?
Mm. Mm.
So identify the type of reaction occurs when NH4 plus 1. Can you tell me the reaction first? What happens when NH4 plus 1 reacts with an alkali? What happens?
Nothing. Um, nucleophilic react? No, that's wrong. Acid plus base.
Yeah, this acts as an acid, right? Because it loses an H, right? And it ends up forming NH3,
Mm.
and the other one forms. So it's an acid base or a neutralization reaction, right?
Yeah, the NH3 and OH, and I was reading CI. That's nucleophilic. The CI is the nucleophilic reaction.
Okay, so we've constructed the ionic equation for the reaction as well. Always remember ammonium ions are basic. Sorry, they are acidic. Substitution reactions of NH3 and NOH ions with halogen alkanes both involve a lone pair of electrons. Name those. So this is nucleophilic substitution. And state the role of. So these were nucleophiles.
Yeah.
You had SN1, SN2 reactions. Anything suggest which species is more reactive,
Yes.
and that is OH minus 1. Why? Because it's got a negative charge.
Mm-hmm.
So it's more attracted to the partial positive carbon atom, right?
Mm-hmm.
Is that clear?
Yeah.
And I'm going to talk about let's say similar carbon was positive, right? And you had 3 nucleophiles coming in.
Mm-hmm.
And there was a CN minus 1 nucleophile as well, right?
Yeah.
So they would all come in and they would attack this carbon that's positive, right?
Yeah.
Clear?
Yeah.
So we've got this. Now, this is clearly a two-step reaction, right?
Yes.
So you're saying sketch a graph on figure 4.1 to show. So this is your SN1 mechanism. Now you have to show your SN2 mechanism, which would probably be a single-step reaction.
Yeah. Like this.
Okay? So it's just going to be it's just going to be a single-step reaction. So that's going to be your SN2 mechanism. Yeah,
Yeah.
and he's asking you to figure out this is your SN1 mechanism that's shown. Okay.
Yes.
SN1 was the two-step reaction. This was SN. So complete and show the dipole. So the first thing that happened was that the Br would break away, right?
Mm-hmm.
So the carbon was positive and the Br was actually. And then Who's the nucleophile? The nucleophile, I think, is NH3, right? Would go and attach. And in the next step, in the last step, it's the H is going to leave, so the Br minus one, which already has left, comes in and takes away one of the H's. Okay, is this clear?
Yes.
कितना रह गया? So let's try and so he's saying identify the inorganic product that formed in the reaction. That's HBr.
Yeah.
Give the systematic name for this thing. So what's the name? What do you call this thing? It's
Dative bonding.
hmm?
Nucleophilic addition.
Okay. Safa Mama, can you try and complete this paper?
Okay.
I have to go for Juma prayers now. Okay.
Oh, okay. Thank you.
So,
What time do we have class tomorrow?
we can have same time.
Okay, thank you. Allah Hafiz.
يا الدراوي